Hi, welcome to this Open Security Summit in May 2021. For this week, we're going to start with a really cool topic, which is about how to prepare for a threat modeling session. And this is something that I think is super important because threat modeling should be part of the activities that we all do as part of the development life cycle. And what we see here is the way the Glasswall security team at the moment, helps and sends out to the teams before we do threat modeling. And we're basically gonna, they're gonna give a presentation, and we hopefully have a bit of a discussion about some of these ideas and the stuff to do to make the threat modeling sessions as productive and as effective as possible. So Petra, Chris, and Abbas, over to you.
Hi, good afternoon. My name is Abbas, and I am the head of IT and InfoSec at Glasswall. So as Dennis, thanks Dennis. So as Dennis said, today we're gonna talk about how to prepare for a threat modeling session. So I'm really sorry, we're gonna start with some basic information in the beginning, like just to go through a couple of definitions, which might be boring for a couple of you. We just want to need to make sure that everyone on the call understand what we are talking about today. On this call, I have with me my InfoSec team. I have Chris, Petra. Chris, if you want to go second slide, please. So I have Chris Holman, our cybersecurity engineers, and Petra Vukmirovic, who is our cybersecurity engineer as well. So yes, basically, so we're going to talk about threat modeling. So if we go to the next slide, please. So just in the beginning, so just to talk quickly about what is a threat model. So it is a process to identify vulnerabilities on an application and how to mitigate them. So if you already have the vulnerabilities, threats, risk, and control, if you have already identified them, so you already have a threat model. What do we use to do that threat model? Like here, we are using the STRIDE attack tree, which is a model of threats, which is used to threat the model, and the pen test. I'm going to talk about the pen test on paper. So when you do a pen test, definitely you need to make sure that you know your threats, your vulnerabilities, your risks, and what controls do you have around, so you can do your pen test and you can mitigate the risks. So it's a structured activity for identifying and evaluating application threats and vulnerabilities. So yeah, so what's a vulnerability? I know most of you know this, and I'm really sorry for being boring. I promise, like Chris and Petra, we're gonna bring the most exciting bit later on. So vulnerability is a flaw in architecture. It's a weakness that can be exploited. It can be a security bug in a code. It can be a flaw in the operation system, in processes, hardware, database, browser, or within people. The threat, it's any vector or agent that has the potential to take advantage of a vulnerability. So at the moment, so we should say that at the moment, so of launch of every safe application should have a valid threat model already. Developers should initiate threat model creation, so to delegate the risk to higher management, which can then either accept the risk or ask for risk reduction controls to be implemented. So basically, when you start developing the application, you should have the developers initiating your threat model. Basically, you work with, you get, I don't want to spoil the next bit, but basically you're going to need, you're going to need to have an architectural diagram, you're going to have a data flow diagram, or work, the InfoSec team should work with the developers and start identifying where the risks can be. So, and if the risk, let's say, the InfoSec team can take and accept, that's fine. Probably we have a vulnerability there that can be fixed quickly or something like that. Otherwise, you're going to need, to escalate that risk to higher management. So in Glasswall, threat modeling is initiated by the development team on Jira. So we have a playbook for that threat model. So what a playbook is, it's a set of questions and tasks that we follow when we do a threat model. So InfoSec assistance is going to be always there. So InfoSec can be sought on every step of the process. So this is an example of Playbook 23 we have, which has a couple of sample questions and tasks we do when you do a threat model. So there are a couple of questions that you're going to need to ask when you are doing a threat model. The team will take you through this later on, but I mean, question that like what security mechanisms apply, what technologies are used, what rights will the actors have, where are the data elements, and then task as like, you need to profile the application, you need to decompose the application, you have the profile, identify the threats, the vulnerabilities, rank, in the end, you need to rank the threats, you're going to go and say, yeah, we're going to accept this one, we're going to mitigate this one, or we're going to transfer this one to our higher management. So I think now Petra is going to, Petra and Chris now will take, will start driving now. I'm on the passenger seat now. Thank you.
So this is just a quick worldly map of a threat model. So basically, if we look at, what would an application need, to be safe, and we can say that, the needs are risk assessment, a completed threat model. But if we look at like down low on the left hand lower end, we can see that there's the threat modeling genesis, and that's done by the development team. And the reason is it's more smoother and quicker if it's done in the design phase. And this is where, the application is still, as in like worldly mapping, the application is still bespoke. It's still kind of in the making. It's not custom made, because this is where the changes are easier to apply. It's easier to introduce some security controls right at the start, right in the design, rather than going back and recoding the whole application and the whole infrastructure. So therefore, this was just a quick map just to kind of show, where is the genesis of the threat model, and where, how we can progress into, a mature threat model at the end. So as we said, as Abbas mentioned earlier, not all risks and threats that are identified in a threat model have to be mitigated. Some of them, depending on the risk assessment, can be just accepted. In the Glasgow, we use this risk matrix, so it's good that like everyone, before they do a threat model, they just get acquainted to the risk matrix, just to kind of get an idea of what are we, at the end of the day, how are we going to be risk stratifying our threats. And over to you, Chris.
Cool. So I guess in a perfect world, you kind of want to prepare your shopping list, and your shopping list is going to be everything that you kind of want before you start your threat model. So the first one is architectural diagrams. If you press enter, it will come up. There we go. So you want your architectural diagram, which will be sort of given from the developers. You want your data flow diagrams, which shows how the data is flowing through the application. And ideally, you'll have some use cases sort of mapped out in scenarios, so sort of user X is going to use it this way, user B is going to use it this way.
Yeah, because sometimes then these scenarios, sorry, Chris, these scenarios can be very complicated. The data flow diagrams can be very complicated if we put all the scenarios there. So sometimes we end up with like a couple of data flow diagrams to represent every scenario, and a couple of threat models to represent every use case in every scenario. Yeah,
naturally, the more complex the application, the more use cases you have. So you've got more data flow diagrams, and it might mean that you threat model each of those use cases.
I have a question for you, Chris and Petra, if you don't mind. So does that mean that you might have multiple threat models for one application?
Absolutely, you can do.
So is that possible sometimes?
Yeah,
for sure. Yeah. It depends on the complexity, right? But the more complex, the harder it becomes to threat model. So if you sort of narrow it down into parts.
Yeah, well, I wanted to say that, we got to, let's say we are doing a threat model for one of our applications. We started a couple of weeks, and we had to go. I think later on when you get to the data flow diagram, Chris, you show that. But I mean, we had to go and prepare for different scenarios, and you might end up with multiple threat models there.
Exactly. Yeah.
So the thing I just want to add here, right, and this is very important from a development point of view, right? Is that these are things that the developer teams should be creating, right? And I think there's a sweet spot here where the security team is basically asking very valid questions, but I think it's very important that there's a really good collaboration here between the development team and the security team, because you don't want to create materials just for the threat model, right? You want to create materials who are part of the way the security team, so the development team, creates information, creates stories, creates architectures. And there's a, I think that the biggest, not a biggest, but a big sort of, hidden secret in a lot of teams is the fact that there's not enough time spending on capturing architectures, capturing documentation, capturing how things actually work. And I feel that is something that we really need to improve. So one of the things I asked to my teams, as from the development side of things, from an engineering side, is that we really need to be creating very good architecture diagrams. We need to create very good data flow diagrams, use case scenarios, and all of these. If you think about it, you almost want to open a risk to a team that doesn't have this out of the box, right? Because I would argue that a mature product, a product that you're selling to customers, a product that you actually are actively developing, you should know all of these, because the developers need this when they are creating their changes, right? The DevSecOps teams need to understand this in order to know what to protect, etc. So I think there's a lot of good synergy here, and I feel that the developer teams really should embrace these activities, because it's almost like it's giving them time to create these materials.
Absolutely, yeah. I guess the more documentation you've got, and like you said, the more diagrams you've got, the better. It makes everything easier.
Yeah.
And the last point I put on there is data classification and compliance, which is an interesting one, really. I mean, it's about how we sort of control data, how we access data. Is it encrypted at rest and in transit, which is one often I kind of miss personally. So it's one to put out there just to take into consideration. Next slide. So this is like a high level architectural diagram. It's of nothing we make, but it's just something I found online, but it kind of explains the bigger picture in a high level detail, just to give you an idea of what I'm talking about when it comes to architectural diagrams. And this is a bit more in depth. So if you look at this, you can now get an idea of kind of what's going on, where the data is flowing, what services are being used, and everything else. And this all builds part of that picture when you're doing the threat model. And then go on.
No, I just want to say, if you go back to the previous one, so the architectural diagram is very important. If you want to get the data flow diagram, if you don't have an architectural diagram, you can't get the data flow. And the data flow is something very essential in your threat model that will allow, especially you mentioned data classification and other stuff. So for you to have a good, to have to know where your data stores are and all of this. So you definitely the data flow diagram, which depends deeply on the architectural diagram. You need to know all the entry points to the system. So in order to do a good threat model.
Yeah, exactly. And the more complete this can be, the better, right? I mean, it is literally the map of the application. So, yeah. And obviously this then builds the data flow diagrams. So off of the architectural diagram, you can then start to map out how the data flows through the system, what services use which data, and sort of you can get that picture of how it all flows together. Use case scenarios. So off the back of those guys, you can then create your use cases. So you can say, customer A wants to do, service B, or in my little bottom picture, you got the student wants to become some sort of graduate. So you can start to map out the scenarios and how the person is going to be using the application, and then each of those use cases create, your individual data flow diagrams if need be.
Yeah, the thing here that I feel is, if you go back there, is that I think is very important is to do those use cases per scenario. And I feel that, a lot of the times the threat modelings get super complicated because you almost mix multiple domains. And I found that if you can start to almost follow the feature, or you follow the particular use case or the particular layer of the application, it helps a lot. It also puts you in places where you know, when you're developing a new feature, when you add a new capability, you get to say, well, you know, if the pattern hasn't changed, you don't have to redo the threat model. But if the pattern, for example, of that feature changed, then that's when we need to evaluate and ask the questions: are we actually, you know, missing any tricks, or have we looked at all the different threats around the system? But I think be able to break down the threat model into multiple subcomponents, and you know, I still feel that the technology challenge that we haven't done just yet, or haven't solved, which is how do you then merge all of them together to get a high level view. It is very important to do that.
Absolutely, yeah. And then just the last one then on compliance. So I guess depending on how your company's set up and what sort of data you're handling with, you might be under jurisdiction to different laws, GDPR, ISO 27001, and that again plays part of the threat model, because you need to know where your data is, and if it's, you know, encrypted at the right level, and if it's compliant against the right certification. So I think for me, it's one that's missed a lot, which is why I've kind of made a nice big screen with different pictures just to get the message over. But I think it's quite an important role to play. Over to you, Petra. Sorry, I was on mute in the middle of a coughing attack.
Okay. So basically, I mentioned the stride approach before, and it's the most common one used in the cybersecurity world. You know, the STAR is an acronym, stands for spoofing, tampering, repudiation, information disclosure, denial of service, violation of privileges. Now, the way to go about it is our approach is that once we have a data flow diagram, we can kind of consider any one of these threats on every level of the data flow. So the way to look at it is every single part of the data flow diagram might have some of these threats, and we kind of have, if we consider all of them, then we can probably say that we've, you know, took into consideration the whole threat landscape, and that we kind of have a complete threat model. This is more kind of, it's not a rule. It doesn't have to be something like, oh, we have to like obey this, you know, as a rule, but it's just a good acronym, like a reminder to have on the side, like maybe next to your data flow diagram, to just kind of, once when you consider all the threats on every level of the diagram, to see you know, what potential attacks and threats you could have for your application. So this is where we coming back to you know, the preparation for the threat model, because when we say threat model, we usually think about like maybe like a joint threat modeling session with developers, the security team, everyone, you know, at the same table, or like online now these days. But you know, in order to make it efficient, sometimes it's really good to have everything prepared, because otherwise you're going to end up with multiple sessions and sessions, while actually everything could have been done in like a preparation. So you know, we took this, you know, we could say that we took these pages from the OWASP book. So OWASP kind of you know, published a lot of the papers how to do a threat model. And we decided to take that model, you know, from OWASP, and it's divided into 5 steps. Now, the step I'm gonna mention all 5 just for completion, but the main steps for this, you know, session is, because we're talking about preparation, it's step 1 and 2. And this is where the dev team comes in. And the reason why the dev team comes in is because, as I said, if they're the ones who come up with the preparation, and they'll be the ones who are going to be implementing the controls, it kind of makes sense that they're involved from, you know, beginning till the end, have like a whole loop. Also because they know the architects, for example, they know the application best. They can describe it best. They know the ins and outs of it. So they know the use cases. So therefore, it only makes sense, you know, for the architects of the application to initiate the threat modeling and do these first 2 steps that are purely related to the application itself. So for step 1, OS recommends profiling the application. So, you know, we have to consider, where is this going to be deployed? Is it going to be deployed on-prem? Is it going to be deployed in the cloud? Is it AWS or is it Azure? ESXi. So it's important for us to determine where is the deployment environment, because every environment obviously carries its own threats and it's a landscape of its own. Then we're going to consider the users, because if the users are going to be wide public use from the internet, it's we have a way bigger threat landscape than if the users are just like certain employees of a company, or just admins. So it's quite important to know the users. Also, as we said before, to know the data flow, you need to know the data elements. We need to know the permissions that these actors will have, these users will have, because it makes a huge difference of if you have a super admin or if you have just a non-privileged normal user. And then as I said earlier, as much as a deployment environment is important, the technologies are important. What operating systems are going to be used, what Docker images are going to be used, what programming languages, what databases are we going to be using? If it's a web app, what is going to be used on the front end, what's going to be used on the back end. Every single technology carries its own inherent risks. So it's important to know which ones are going to, what was going to be our tech stack. And then we have what security mechanisms apply. So what is important to our client? Does our client care mostly about integrity? Does our client mainly care to have its data untouched? Or does the client care more about confidentiality, that nobody sees any of the data that's flowing through? Or does our client care more about the availability, that it's, the data is always ready, accessible? Because this is important, because depending on that, we will change the threat model. Because if a client is not so fussed about availability, but they care a lot about confidentiality, we're going to implement different measures, different controls to mitigate some of the threats that we find. And then we have number 2 is basically decomposing our application. It's just going down into the nitty-gritty of it. So, first of all, where are trust boundaries? So, example, if we have Kubernetes, is every cluster going to have its own trust boundary, or do these clusters actually trust each other? Where does the internet lies, which is completely untrusted? What is in scope and out of scope? Like, is sometimes some parts of the applications are out of scope of the threat model because they lie on the client side. The customer side. So the customer is responsible for implementing, some parts of the application itself. So it really matters where trust boundaries are, because also the threats change as much as we change the trust boundaries. Firewalls. Where are we going to put our firewalls? Where it's gonna, where our web servers and databases are going to be, how are they going to be communicating with their services? Of course, if we're going to integrate some external third-party services, that also matters, because the threats can be different. Where are the entry points? Now, this is super important, because if we have some threats that are present on one of our services, but there's no entry point to that service, those threats can become irrelevant, because if that service is locked down and nothing has access to it, the threats become non-applicable, out of scope. So it's really important to know where's our entry point, where is, that kind of determines our threat landscape. And of course, that comes back to like, all our ports or our APIs or our stored procedure, everything where lies. Obviously, egress or exit points matter as well, again, because same reason for entry points. And then, for web apps, like it's important to know where we will display our data, where our functions be sending out values. Then it's important to know all the data flows, as we said. This is where on step 2 we do our data flow diagram. So I'll show, like, later, there's a list of tools that we can use. None of the tools are perfect. Sometimes you end up using a couple of tools. A lot of times it comes down to your own preferences. as long as you capture all the data flows, and as long as you think about all the threats, at the end of the day, it doesn't matter as much. I find the Microsoft threat modeling tool quite handy because it, if you do the data flow diagram correctly, it will display a nice list of threats. A lot of them might become not applicable, but at least you have something to go through and to check, kind of, a checklist. And then,
I hope we can present it better at the end of this.
Yeah,
if we have time, so we'll
if we have
something.
time. And then, data validation, of course, it's always important. So, this is, for example, a data flow diagram, like in the making, how we would create these data flows. This was done on a threat modeling session live on one of the Open Security Summits. So sometimes you can do the data flow diagram live on a live session with the developers, but then that can mean sometimes you end up doing the whole session just doing the data flow diagram, which is, it can have its values as well, but sometimes it's good to at least have the developer try and do their own data flow diagram as a start, as I said, as the preparation for the threat model. And the reason is then it can save a lot of time during the live session. So yeah, I'm gonna go through these steps just fairly quickly. Oh, was it Chris, you that you're gonna go through?
Yeah. So
sorry. Okay, on to you, Chris.
not going to spend too much time on this because we have actually got a live threat modeling session on Friday, which we hope you can all join in with. But step 3 of this process is to identify the threats. So you want to sort of, like we said, once you've mapped out everything, you want to go through it and identify where the threats are using the different methods we got on the screen. And then once you've identified your threats, you then have to identify the vulnerabilities, which I think is the next slide, Petra. Yep, so you identify the vulnerabilities, and we've said it's InfoSec and Dev. I mean, to be honest, it's not just these 2 teams. It can be anyone identifying vulnerabilities. Anyone who's looking at it with a keen eye can probably spot stuff.
It can be SRE team sometimes, the ones who will be maintaining the application. So
yeah, I guess everybody really plays a part in sort of identifying the vulnerabilities. And also, I mean, some of the tools you use, it does give you like recommendations, and it spits output to say, this could be a potential weak area. So it's another area for sort of manual investigation, if you like.
Yeah.
And then the modeling process, practice. Do you want to speak through this, Petra? Because I haven't quite looked at this.
Yeah, sure. So basically at the end, this is just, I'm gonna tell this quickly, because at the end, basically, when we have our threats, we have to rank them, because obviously it's important to delegate the work. So prioritize the work, because dev resources are always hard to get, especially for security. So we really want to make sure that if we're going to be using development resources, that we use them for the right threats, to mitigate the right threats. As I said earlier, for example, we shouldn't be mitigating some threats that are actually not even applicable or out of scope for us. So, to rank the threats, there's a lot of things that we can kind of think about.
It's another session, to be honest.
It's another session. Yeah, exactly. It's a whole new session. But, at the end of the day, if, we can use various methods, but at the end of the day, we have to choose whether we accept, mitigate, transfer, ignore a risk. So just to wrap up, like some of the questions that you can actually ask yourself as well, when you're preparing for a threat model, is like, you can always think about the OS top 10, because even if your application is not vulnerable to any of those, it can always be kind of like a landmark for you to if you think about all of these things, and it can remind you of some other potential vulnerabilities and threats that you might have missed. So it's always good to go back to the good old OS top 10, and then you can think about how safe your API is to intrusion. What protocols have you used? also, like, one thing that can be sometimes a constant struggle is API keys. Are they going to be exposed anywhere? Is that going to expose your application to threats? Because like you can have the most secure architecture in the world, but if a API key gets committed then to the code, then everything collapses and it becomes the application itself becomes
And that
vulnerable.
happens a lot, by the way. So it happens everywhere.
Yeah, it happens. That's why we have like the tools to detect that. And then, like Chris mentioned earlier, the data is important, data classification, especially because, if there is some non-confidential data, we don't really care if it's encrypted at rest in transit. But if the data is highly confidential, then we want to think about encrypting it at rest and in transit.
So if you are processing customer data or like even like your organization, like on like confidential data, like personal records and stuff like that, you need to make sure you are protecting that data by encryption at rest and in transit.
And also, like when you think about your attack trees and stuff, like what can attacker do to get access to your web app? But then what? Like sometimes even if they do get access, but if it's a non-privileged access, then they might not be able to do much damage. And depending on their skill, again, they can do privilege escalation, of course. But that becomes something like that's less likely. So first step would be to try and defend yourself from the lower skilled attackers, and then you need to think about, okay, so if they manage to get in, can they do damage? If they can, then that's worrying, and then you need to implement controls. But
you limit it.
Yeah.
Sorry.
So you have to do, you have to implement controls to prevent privilege escalation. But if once they get access, actually this access doesn't provide them a lot of a lot of information, it doesn't disclose much, it doesn't give them a lot of power over your application, then it's also important in when you delegate resources to what threat you're going to fix, to think about this question. Now, the threat modeling tools, as I said, there's quite a lot of things that you can look into. The OS Threat Dragon is actually quite similar to the Microsoft Threat Modeling tool. So I'm going to show the Microsoft Threat Modeling tool just quickly. Yeah, and I'll show that after we finish. But at the end of the day, it doesn't really matter. You can use just draw.io. As long as you write a data flow and you think about like the stride threats on every step of the way, I think the method that you use, it's not that important. I mean, people obviously everyone can disagree. Yeah.
The biggest thing would be just to question everything, isn't it? Ask as many questions as you can and question every part of the process, because questions generate talking points, and talking points often lead to, oh, I didn't think that was there, or oh, I didn't think this should be doing this. So if you question every part of the process, you get to some good, you uncover some interesting stuff.
Yeah. And that's it. Yeah. I'm going to show you, before we go to questions, I'm going to just quickly show the Microsoft Threat Modeling tool. But I'll stop sharing for a second.
I'm sure you have it installed.
Yeah,
is that on your Mac? Is that on your Mac?
No.
Okay.
Okay, 1 second.
Petra had a new Mac, so she's missing a couple of applications, but she's not using it today. So.
Yeah, if I had my Mac today.
Turn to the dark side.
I've been brainwashed by devs to get a Mac. Okay. Share screen. Okay. So everyone sees the Microsoft Threat Modeling tool?
Not yet.
No.
Oh. Yeah, I need to. How about now?
There we go. Yep.
Okay, so it's quite simple. You know, what you can do is you start off with, you know, some possible, like if you're doing a simple web app, this one is made for Azure, but you know, it can be very generic as well. So what you do is you start off with, you know, when you do your data flow, you think about like, where does everything start? Where does the flow start? So you can put like a browser because someone accesses a web app, let's say through a browser. And then you can potentially have,
Web app.
yeah, where is it now?
It's just pass through. Can't you search? I
Yeah,
think you
yeah.
can.
So
Yeah.
yeah, so we have a web app, and then you know we can have a web API, and we can have a
Database probably.
Where is the database?
It's the Azure database for
There we
MySQL,
go.
whatever.
Okay, and then yeah, let's keep it simple. So, and then we're gonna have our trust boundary. So for example, like a generic trust boundary. So we can say that, you know, the browsers where it's, you know, everything is kind of untrusted and unknown. But we can also, you know, if we really want to protect this SQL database, we can say that the SQL database will be in its own trust boundary and it shouldn't trust anyone. So we can put it like this, and then we can put another trust boundary here.
This is the line, Petra. Oh yeah, you don't know. Okay, sorry.
Yeah. And yeah, and then we can connect it, you know, with the generic data flow. But then, you know, when we connect it, you think about, okay, so how is the communication? Is it HTTP? Is it HTTPS? So most of the time it's actually, you know, we have a request and a response. So actually we can just do it like this rather than, you know, have this one. Request and response. And let's do it here. Okay, we did it the wrong way around. I'm not gonna beautify it. Okay, and request and response are the wrong way around here as well. Okay, so let's say we have this, you know, created this simple data flow, but a lot of times it becomes super convoluted and super, you know, you have like a lot of services that communicate with each other at the back. Or like if you're talking about Kubernetes, you know, within clusters, you can have a lot of services communicating with each other. And that's why sometimes it's, you know, this whole thing becomes like a spider web, and that's why it's better to do the use cases, the scenarios, because that's like, okay, what happens in this scenario? And then let's just draw how the data flows in this one specific scenario, and then let's just do a threat model based on this, rather than creating a whole spider web here with lots of services, lots of arrows going back and forth, and it's not really clear what's happening. So yeah, so then what happens is, the good thing about this is that then you can view the threat list, which for some reason
Go to analysis view, isn't it?
Yeah, there we go. So yeah, there we go. Now we have a generated list of threats. And you know, the severity is here, but that's arbitrary. Like we have to be the we have to arbitrate this. Like, is this actually high? Like, we go through every threat. We think about what happens at every level. So, for example, here and here, and then we can make comments on it. We can say like, this is not applicable for this reason, or this is, even the threats that are like, for example, marked as medium, we can escalate into high if we think that's important to the client. So
it depends on the environment and where you are. That's what Petra was as well, like discussing before she got to the threat model. So it depends, on the environment, because let's say you might have a vulnerability somewhere, which is, in an environment which can be like a high risk to the whole product, to the whole application. But in some scenarios, it might be just isolated. You can't execute anything you can't exploit it. So it should be fine. So it can be, you can't just accept and say, this is a low risk for me. So here, depending on each scenario, you can go and, and set the severity on a specific value.
Yeah. Okay. Well, I mean, we talked a little bit about how to prepare for a threat model. The main thing I would put, I would highlight here from the whole picture is the data flow diagram. I think that's super important to prepare for the threat model, because if you get that right, it's very likely that you're going to get your threats right, because that's the most important thing. That's like the core of the application, the beating heart of it. And all the other things that we mentioned before. I'm just kind of curious, anyone who's been doing threat modeling before, what do you think? Like, how do you prepare for a threat model? How would you do it? Do you agree or disagree with us on anything? If anyone has got any comments.
Looks like we're doing it the perfect way.
Yeah, seems like we're doing an amazing job. Awesome, good stuff. Okay, so any questions?
Yeah, for the devs in participation, what's your views, and where do you guys see also this adding value to some of the workflows that we have?
Well, I guess we should start utilizing those tools. Well, it's really what's interesting what Microsoft did for this approach. They actually, once you draw the diagram, they can identify the threads, the common threads. So they prepare the list for you, and you just need to go through that list. You don't have to generate that list yourself. Miss something.
Well, I would add this, because you always have to, don't rely on the machine too much. Okay. I know we're in tech, but this is why the human touch is super important in a threat model. Is even despite the fact that Microsoft has thrown you a list of threats, your environment may be very unique.
Absolutely.
And you have to think about, is there anything here that's not mentioned?
This is a starting point only.
Say again?
It's just a starting point where you can start.
Exactly.
I mean, we had an example before. I mean, we can't show it probably on the next session. Probably we have a slow roll. Loris, remember Petra, and that was dependent on the environment. So I mean, you can't rely much. I mean, like the tool was saying like we low Loris is a high risk, but in one of the scenarios it was not a high risk. It was not isolated, and in the other scenario it was very high risk. So in the end here, like technology, the automated thing can give you a lot of stuff. I'm not saying it's bad, but you always need the human element here, because you know your environment better than the automated whatever like security tools you have in there. So you're gonna need to put your human touch there. The application, how it works. So
I think also the output does spark a conversation there, doesn't it? Because you have to go through them, and each of the outputs, it generates a conversation, and then from that conversation you can stem further down. So
you can even identify some things that are not here just by talking about every single that's here.
It's always healthy to have the developers and everyone, like I mean, most of people who are involved in the product life cycle might be useful, because you can bring one conversation that you like security team didn't even say it, and you have other people input they help you. And how many times did we change things because someone said one word and suddenly you go and change, you start seeing more stuff. So it's a collaborative work on here between the dev basically and the infosec and other players. But I mean, dev and development and infosec are the main players here, and every single thing matter. And that's why we always say in a security awareness training, which is a generic thing, it's even if you think that the threat, you're not really sure if this is an incident, security incident or not, just please make sure you report it. And I would always say to developers, even if you think might be not valid, this thing might be not valid, just mention it, because it might open your eyes on other things.
Okay. And well, I believe those tools will be helpful in identifying identification of common threats. And what if some threats just comes that is not explored, that isn't, or is just identified by some security groups, but is not in common availability. So information only is being collected, and it accidentally applies to your project, to your software. What we do with that? Well,
yeah, it's important to always think about your own specific use case.
We have a question from John
Yep.
Knox. What are your views on the evolution of threats over the lifetime of the application? I'm thinking about the change of perceived risk with some users of SolarWinds. Okay, so.
Well, in regards to SolarWinds, it's a whole new discussion, but for example, so that's a really great point, because a lot of times as the evolution of the application goes on, the architecture can change.
Yeah. So what we say all the time is, let's say we have an application as a part of compliance and other security stuff. We do, let's say, one pen test in a year. But sometimes if you have an big architectural change to the design, big development work being done on the application, will change a couple of things. You need to do always to redo your threat model, and after that probably do another pen test, because that might change the data flow, your entry points. So, and that might create it might be for the good or the worst, but you always need to have a in case of an architecture, as we explained with the team, that the threat model depends too much on the architectural diagram, which creates the data flow diagram, and on the data. So if the architectural diagram changes, that means probably the data flow will change, which means that your threats, you might have more threats or you might have less threats. So that's why you always need to redo it. You might need to redo a scenario, or you might need to do the whole threat model.
Yeah, look, the reality is that when those incidents occur, the investment that you've done on threat modeling, the investment that you've done on mapping, on creating data flow diagrams, understanding how the application works, and keep everything up to date will really pay off. Because in a way, for example, answering the question when SolarWinds hit, which basically means what happens if I don't trust this particular component, that should already be in a way part of your original threat model. But at the time you would have said, well, we trust it, right? We're going to trust that particular component. But when the threats change, my view is that when the facts change, your threats change, right? When you're going to be making a whole bunch of assumptions in your threads, and facts are great risk absorbers, right? You can say, I have a fact here that I trust this, I trust that, this is not a problem because of the data that we have doesn't support that to be a problem. But when the facts change, you have to revisit the threat model, right? And I would actually say, look, a pen test it's a way to validate your threat models, right? So in fact, if your pen test finds anything that has not been identified in your threat model, then that's a risk in itself, right? Because it means that there was a gap in your workflows, right? When you do a pen test, you should not view it as an adversarial relationship. You basically should say, how can I get, this external team who's taking a different view on the application to basically validate our current understanding and our current almost like awareness of the situation.
It's also a good verification, isn't it? The pen test, it kind of verifies that you've done the threat model correctly, I guess, because it picks up stuff that you might not have thought about.
Absolutely.
And to add to on what Dennis said as well, in terms of risk acceptance and mitigation. So you might be at day one of the application, you might say, I want to accept this risk because it's going to cost me like £2 million. The whole application is worth 1 million. But after like a couple of years, like you might say, oh no, I need to, I can't accept this risk. I need to fix it. And in terms of threat model, the threat model would change. So
cool.
It could be the threat landscape rather than the app changed, though.
Yeah, no, that's a good point, and that's what Dennis just elaborated.
Yeah.
If you would have trusted some components before, maybe you don't trust them anymore because they turned out to be much more vulnerable than you thought. So yeah, I think that's a really good point.
Yeah, good questions.
Yeah.
Cool.
Any more questions?
Not from me.
Okay, well, thank you.
Just to wrap up. So what's the list, right? Where's the actual list of, for a team to, you want to end up with that one, right? Like, what if a team is doing a threat model? In fact, some of the members here on this presentation are going to be here on Friday, right, for the threat modeling session that we're going to do. So what should they prepare in advance for that session?
Well, I think the wrap up is basically, let me share my screen again.
Yeah, and what we start with Chris' shopping list.
I would actually say the playbook. I mean, yes, start with the shopping list because it's a general overview. But 1 second. Can you see my screen? I think you're
we can see your screen. We can see the other screen, but that will do anyway.
That will do.
Yeah.
Yeah, this one. So that's basically it. Think about these questions, execute these tasks, and especially for the preparation bit, as I said, you've got the step 1 and 2 from the PowerPoint presentation. Identification of threats, vulnerabilities, ranking the threats, that can be done on a threat modeling session. Creating a data flow diagram is super important in preparation for a threat model, and thinking about all these questions here. So that's the cookbook, the playbook for.
So basically a couple of steps. You need to identify your use case, what asset do you want to protect, what is affecting it, like external stuff affecting it, your trust zones, as Petra, we went through the threat model, what can be the threats, basically to check on what is the anyway, I mean, determine like your high level security objectives to address what are the potential threats, what are the security requirement for every, you need to identify your requirement as well in the beginning.
Mm-hmm.
And definitely you need to have kind of a documentation for all the relevant information. And step 2, you went through, Petra, on the slides, like decompose the application. That's a very important bit as well. And then go and do your risk rating. What did you call it? Risk rating, and after that, deal with all the vulnerabilities.
Yeah, we need to create a version of this for GitHub issues.
Yeah.
Yeah.
Cool. Well, there you go. So let's try to have another session next month or the month after, where we bring a couple more people experience and have a round table on their experiences and then share some information. Good stuff.
Cool. I invite all of you to be on Friday session, right, Petra?
Yeah.
Yeah, on Friday session. it's like, this is like part 1, and part 2 is going to be something in action. We're going to do a proper threat model there. So you would definitely love it. Yeah, so that's, you're going to love it. So it's going to be in action.
Cool.
All right.
Awesome.
Thanks, everyone.
Thank you. Cheers.
Yeah, cheers.
Cheers, guys. Cheers. Bye.
Bye.
All right.
Hi.
We can stop the recording.